Do you want to stop sharing your screen and try once?
Hello, can you hear me now?
Yes, yes, I can.
Okay, thank you.
Let me just introduce you, sir, and then we can begin.
Yeah.
So this session is on GE's perspective, and we have Mr. Ajay Vajpeyi, who's Commercial Proposal Director, AQCS India, GE Power India. He's currently in charge of tendering and tender engineering for air quality control systems. He has domain expertise in air pollution control systems. He also has experience in functions such as research and development, process engineering, field engineering, commissioning, and troubleshooting relating to various AQCS equipment both in India and overseas. His teams have been instrumental in the acquisition and execution of various projects in the area of particulate and gaseous emission controls at large power and industrial plants. A very warm welcome and thank you for sponsoring the conference as well. We can begin with your presentation now, and after your presentation is done, I'll take questions.
Thank you. Thank you for giving me this opportunity to be here in presence of this august audience. So today what I would be presenting would be the FGDs in as per GE's perspective in the Indian context. And I have limited slides, a lot of material, but keep me in check if you please ask questions if you want to know more.
Sure.
So the first dilemma which an end user sees from his side whenever he's looking at the emissions control or SO2 emissions requirements on a project, he's got a multitude of questions in his mind. What is the solution he should propose? Whether he should go for dry scrubbing or wet scrubbing, what kind of scrubber should he go for? Should he really maintain the same fuel or make changes to the fuel, make changes to the boiler? So all these kinds of questions will come up in the mind of the end user, whoever is trying to build an FGD or look at the ways and means to bring down the SO2 emissions on a power plant or a utility boiler, or for that matter, an industrial boiler. So what we at GE basically try to evaluate is basically the size, the capacity, unit size, the capacity factor, the service balance life, the sulfur content in the fuel, the emission limits which a plant needs to meet, the space which is available in the plant, the cost of reagent and quality available, and what are you going to do with the byproduct. We look at these questions whenever we want to solve the problem which an end user sees. So in India, we have been participating in various bids and tenders, and uh, with the grace of God and with support of all the team members and the organization here, we have been able to we are executing a number of projects. In this next slide, what you see is the projects which we are currently executing. The ones in black are the wet FGD projects, which we are primarily executing for NTPC. Then the plants in green are the existing installed seawater FGDs, which are already running in the country. The installation in blue is our Vindhyachal wet FGD installation, which we had commissioned, and is probably the first large full-size FGD which was commissioned and installed in the country. And then we are, as we speak, in yellow, we see the dry FGD, semi-dry FGD, which we call it, being installed and currently under execution at Aditya Lapanga Captive Power Plant. So we, if you see the list, we have plants varying right from 150 megawatt going all the way up to 800 megawatt, which we are currently executing. And a wide range of technologies being put into play, including semi-dry FGD with the lime or with limestone wet FGD or the seawater FGDs, which are currently installed and running in the country. So this is an outcome of the problems which have been solved by the end customer. But going forward, we wanted to share with you the perspective which we feel is a big critical importance for the end customers. So fundamental challenge which we see in the country is the cost of the lifetime cost of the installation, which is the opex and capex. So this is something which everybody needs to look at from a perspective of how big the unit is, what is the residual life left in the plant. Then we need to look at the ease of execution of the project, in the sense we need to know how much space an end user is having in his plant. How are you really going to install the plant? How are you going to set up the layout? Whether there are any supply chain constraints from the suppliers, or you would go for domestic sourcing or go for imported sourcing. So those kind of things need to be looked at, and then the overall time schedule to execute. This is something which we really need to look at when we are looking at the execution of the project. From an operations perspective, we need to look at the availability of the reagent, the usage of the byproduct, the use of water. And from a regulatory perspective, definitely the emission measurements is a key parameter which will tell us whether the plant is in compliance or not. Then you look at tariff approvals, because that is where the money comes in for the plant owner. And then the timeline, whether if we are having delays, whether there will be penalties or so imposed on the plant operator. There are always cheaper and alternate technologies which are also available, but yeah, this is what we look at. So on this screen, what you are seeing is a picture of a work which we are currently executing. It's just superimposed on a Google Maps. This is an old clipping. So definitely this is not giving you the complete perspective of the state it is currently in. This is from one of the projects which we are executing for NTPC, where we are looking at almost 36,000 meters square of space for installing the 2 into 660 megawatt FGDs on the power plant. Definitely this will vary from plant to plant and on the overall specification requirements by the end customer. But this gives you a flavor on the size needed to install a wet FGD plant with the kind of specifications which we are having in the country, including limestone storage and the gypsum storage. Whereas on the picture on which you see on the right is more for the installation of a semi-dry FGD. For a 2 into 300 megawatt plant, we are looking at somewhere around 6,000 meters square. So fundamentally, a lot of space is required when we go in for a wet FGD system, whereas far lesser space requirement when we are looking at semi-dry FGDs. So this is a technology to look for when we are looking at shorter plant lives or residual life in the plant, and when we have space constraints. Then other than that, the biggest issue which we see in the ongoing projects is the construction challenge owing to the limited space. There are a lot of civil work which is needed on a wet FGD plant. There's a lot of erection activities which is needed. A lot of lay down area is needed. New buildings need to come up. So it's an extremely tight space to work at. With all the and in the current COVID situation, this work has even become further difficult for the EPC contractors to execute. Whereas when we, this is another picture giving you a perspective of the chimney foundations being cast or the absorber shell erection. So it's an extremely detailed amount of work which is needed. Many people ask that you should tell us what will be the cost per megawatt. And I must confess in this meeting that it is extremely difficult to work out cost per megawatt. It varies from site to site. It varies from plant to plant. It looks, we need to look at what is the kind of soil which is available in the area. What is the underground situation in the plant, whether we need to go for piles or for standard foundations, what would be the depth of foundations, and all those kind of things which will determine the overall quantum of work, timeline of work, and the overall cost of the project. So what we see on various projects, like many people are talking about 18 to 24 months or 26 months for execution of a wet FGD project. I must confess that it's an extremely unrealistic schedule. Unrealistic because there is an extensive amount of site work needed on a brownfield project. There are multiple fronts which you need to open when you are executing an EPC contract or you are executing civil work and M&E works which are needed in the plant. So you saw the area which I talked about, almost 36,000 meters square. So it's a huge amount of area. Every project and every site is different. Engineering for each of the site needs to be done separately. Full 100% engineering needs to be done for every project, and each project is different. Then there are constraints on deliveries from local vendors, which are not suiting the current completion schedules. There could be monopolistic situations of some sub vendors for a few critical items, which leads to supply constraints. So I must tell to the end users that they should really look at project schedules with an open eye, keeping in mind the overall site space available and the overall ease of carrying out the execution at site. It's not really installation of the FGD which takes time. It's more of construction, which really takes a lot of time. And construction is hardcore work which is needed to be done at site. Another parameter which we are worried about, we look at construction water. Many a times the end customers want us to arrange construction water. Please understand the customer who is owning the plant is best suited to locally arrange for water. The EPC contractor does not have the local presence to really look for construction water and plan that in the for the costing or execution of the project. This should preferably be arranged by the customer and provided to the contractor for carrying out all the civil works which are needed amount in that area. There is huge amount of underground and unforeseen risks on an existing power plant. And many a times it is expected that contractors should take care of the underground and unforeseen risks on a project. It is almost impossible for the EPC contractor or the contractor who does the FGD to estimate both budget and time for such risk in a systematic manner. Many a times it's just a guess, and then the problems are seen during the end of the project. Titanium is one of the materials of construction. Many a times people ask for titanium as a material of construction for portion of ducting and chimney flue can. And this is something which we get extremely worried about because significant precautions need to be taken during welding, including shielding to prevent its oxidation. So whenever you're welding titanium, you need to shield the location. And carrying it out at site location, at site conditions is extremely difficult. Imagine a person working at elevation of 40 meters, trying to do this kind of work where it's very, very difficult. Then what we have seen is in many projects, there is extensive usage of high nickel alloys. Few bids, in fact, there are few bidders who call for high nickel alloys, including piping at times. So this is cost prohibitive and not really needed. There are reasonable alternate solutions which are available in the market, and it is not really needed to have high nickel alloys for corrosion resistant duty all the time. This finally what it means is this is the cost of compliance which will go to the end user or the electricity consumer, and we should look at cheaper and alternative solutions for availability and execution on project. Another problem which we as OEM we face is that payment terms on contracts are pretty with very low initial advance, and there are significantly high retentions on the project, which lead to adverse cash flows. And it becomes extremely difficult for an organization which is working on projects to really come up with to fund the projects. So some of these thoughts which I had. Then other than that, I just wanted to talk about ease of execution. There are semi-dry FGD technologies also available. There are wet FGD technologies, and we just wanted to present ease of execution. So when we look at wet FGD, we are looking at high nickel alloys, specialty metals, welding techniques which need to be taken care of, high alloy for high alloy linings. There could be glass or rubber plate glass lining. Whereas when we look at semi-dry FGD, not really very difficult materials. So specialty steels are not needed. High nickel alloys are not needed. So not really an issue. Suppliers, we find that there are limited EPC contractors, and There are limited suppliers for items like pumps, mist eliminators, oxidation blowers, agitators. These are key equipment. Whereas in our case, when we look at semi-dry FGD, there are a number of items which we manufacture as per our own design. There are limited suppliers in the country, but we believe that if in case there are volumes, we can always get contract manufacturing done within the country. The biggest item which all of us should be worried about is the overall quantum of work. And you look at it. We are talking about almost 30,000 plus tons of meter cube of concrete, almost 9,000 metric tons of erection, 30 kilometers of piping, could be more. We are talking about 2,700 valves or field instruments, almost 350 kilometers of cabling, almost 15,000, roughly around 13 to 15,000 cable terminations, huge number of IOs for controls. Whereas in the alternate technology, we are almost looking at much lower numbers in terms of each of these parameters when we look at the overall quantum of work. Construction feasibility is very difficult for a wet FGD plant on an existing running plant. It's a nightmare for planning and construction people. Whereas we see limited concerns when we look at semi-dry FGD because it's less complex. So what we should say is the customers should order out the projects early, give time to the contractors to really execute as per the quality and time needed. 24 months or lower is not something which is executable. It is something which is going to create pressures in the project and not really something which will give you a plant which will operate for a long time with trouble free. It's very, very difficult to execute such projects, which we are learning the hard way. We took up some challenges, but we're still learning the hard way. Reagent availability is also an issue when we're looking at high purity limestone in the country is very limited, and this becomes a constraint for high quality commercial gypsum. We expect in the country that gypsum will be used for the cement industry, but gypsum demand also has seasonal variations and there would be limitations in gypsum offtake. So the rules for disposal need to be laid down when you're looking at gypsum. Then the amount of water which is needed for saturating the flue gas and bleed off is limited because of halogen buildup in the system. And wastewater which is generated within the FGD needs to be treated in the wastewater plant. If a ZLD needs to be installed, then that is something which will reduce the water disposal, but that is an added cost and complexity in the power plant. Whereas when we look at semi-dry FGD, we know that good quality lime is available in Rajasthan and MP area. Some amount of work needs to be done, but this is available. The byproduct is potential usages in road construction. We are still working with some organizations to come up with some clarity on this. Apart from this, disposal in landfills can be done, and rules for byproduct disposal needs to be laid down. And then from a semi-dry FGD perspective, the amount of water which is needed is limited, and there is no wastewater or no ZLD which is coming in the system. So this was just what I wanted to share in this short and limited time. And I'm leaving myself open to questions. So please be free to ask questions.
Thank you so much, Mr. Vajpeyi. If you can stop sharing your screen, there are a bunch of questions which have come in. I'll just take them.
Okay. Just one moment.
Done, sir. Done.
Okay.
Okay, sir. So the first question is that how different it would be to implement FGD for supercritical plant having 800 megawatt than a subcritical power plant of 210 megawatt?
So from an FGD perspective, whether it's 210 megawatt or it's 800 megawatt, there is no fundamental technical differences in the technology. It's just a question of size of the equipment, the size of the absorber, the size of the ancillary equipment which are needed, and that's all. Typically, what we have also seen is many engineering companies, they come up with common set of specifications for the availability or the sizing of the equipment. And what we find many a times is that such the sizes of what is available in the market or what are the subsystems available in the market needs to be looked at before really deciding the specification for individual equipment in the power plants. Other than that, we don't see a major issue when we look at this 210 versus a 800 megawatt plant.
Okay. And have you maintained 150-meter distance between existing flue and new flue in your completed FGD plant?
So this is a technical requirement which has been specified many a times by NTPC, and this is coming from a basic fact which is being actually what happens is many a times the distance between the old chimney and the new chimney is not specified by the end user. Then they expect the EPC contractor to come up with a strategy to mitigate this. And this is something which we found is technically very, very difficult in the sense you need to really carry out detailed studies before you can really decide what is the real distance or what is the interference caused by new chimney on the existing chimney. Many of the contractors or many of the specifications also call for design changes to be done to the existing chimney, which is a technical impossibility in an existing plant. So NTPC has been very, very smart when they had specified this. They evaluated this problem from their perspective and then took a decision that if it is a distance of 150 meters is maintained, there is no cross impact which will come on the existing chimney and which will not, and they will probably not have any design changes to be done. So fundamentally, that is a solution which NTPC had adopted and a very wise solution adopted by them. Some of the other specifications don't have these details. They expect the EPC contractors to solve this problem, but we cannot really solve this problem till the day we know that whether these detailed studies for stack or the wind tunnel tests are done. We cannot really do that kind of an assessment. You also need design details of the chimney which are not available many times with the contractors. So this is a typical problem which we face and we try to resist, but decisions have to be taken by the customer on this, and studies need to be carried out in advance before awarding the contract.
Okay. Next question is, sir, if you could, 1 second. What is the cost differential in single flue and twin flue?
What we have seen is looking into the overall construction, the materials of construction in a flue can or in a chimney. Single flue can turns out to be more cost effective than the twin flue cans, simply because of differentials in heights which are needed because of the or the height of the flue can decide, the height of the chimney decides the overall cost. So we find single flue cans to be a cost effective alternative to multiple flue cans.
Okay. And how do you control the outfall seawater temperature from absorber in seawater FGD plant?
In seawater FGD plants, you many a times have cooling channels which are there to cool down the seawater which is going out from the FGD. And apart from that, you end up doing a certain amount of dilution so that you can control the outfall sea temperature, outfall seawater temperature into the seawater.
Okay. And do you have
To
any
meet the
project
norms.
reference? Okay. Any project reference where integrated absorber and flue are used together?
We in India, there are no plants where such designs have been used, but there are projects which we have been with GE overseas have executed, where we have the integrated absorber and the chimney. The biggest constraint when you're looking at that design is again a schedule from a schedule perspective.
Right. And can we go for dry FGD for power plant less than 150 megawatt? What will be the capex and opex?
Difficult to roll out capex and opex on this presentation, but this is always there. We are already executing a 150 megawatt. You might have seen in the list of installations which we were talking about on the current projects. So definitely smaller plants can go in for dry FGD, and it's typically much cheaper in terms of to the order of around 20 to 30%. But the major cost is decided by the quantum of civil works which is needed on the plant based on your requirements.
Also, if you could throw some light on wet stack liquid collection pipe MOC inside in the flue.
So there are multiple technologies which are available, and different materials. Which are allowed. Those typically would have to be corrosion resistant materials. So a choice of them is available. It could be nickel alloys, it could be titanium, it could be FRP. Lots of choices are available.
And what is the approximate amount of compressed air requirement for wet FGD for 600 megawatt thermal power plant?
You don't really need any regular requirement of a compressed air for a wet FGD system. Some amount of compressed air is needed for actuators, which are pneumatic actuators, which you might have in the plant, or for some fabric filters which you might be having as far as the dedusting systems are concerned. So technically on a regular basis, there is no regular requirement of compressed air for the plant.
So there are 3-4 more questions. I'll just take them if that's okay with you.
No problem.
1 second. Is the gypsum quality dependent upon wash water quality?
The wash water quality is basically needed to control the amount of chloride which you will get in the gypsum. So from that perspective, the wash water quality will determine the amount of chlorides you might have after the wash. Other than that, the quality of gypsum is governed by the quality of water which you will have in the plant and the limestone quality which you will need to have in the plant. Or if there is any dust coming in from the ESP to the absorber.
And what should be the typical timeline for commissioning of 1660 megawatt unit?
Again, as I told you, people are expecting that needs to be done in 24 months, but we need to look at on a case-to-case basis. And I must confess, there are schedule requirements which are typically being driven by the construction possibility or ease of construction at site. The more complex the construction, the more compact the layout, it will be, the longer would be the schedule needed. So it has nothing to do with whether it's a 660 megawatt or a 800 megawatt. It's just that the overall sizing of the ancillaries and the feasibility of construction and civil works would determine the overall schedule. It can vary anywhere between 30 to 36 months, depending on the accessibility and the availability of fronts in the given plant.
Answer: your target removal efficiency will remain the same when limestone purity reduces?
Well, we are putting up the FGD to meet the emission requirements. So that is what you would set your basic design for the SO2 capture. If you were, and then you should actually go and search for buy limestone as per the required quality to meet the emission norms. There's no fun having FGD which will not meet emission norms because you don't have the proper reagent.
And does semi-dry FGD take less time in implementation?
The semi-dry FGD is faster to implement, but again, much faster than a wet FGD system because this is overall system level interfaces are far lower compared to a wet FGD. And the overall quantum of work which is needed at site is also lower. So it is from that perspective that the overall schedules come down.
And the drains collected in wet stack, can they be routed to absorber?
Yes, and that is what we typically do.
Okay. And chimney liner, what type of modification is required?
In the existing chimney, there are, if you want to use the existing chimney, then you need to line it with corrosion resistant materials. Borosilicate is a good choice to go for. Then other than that, there are people who go in for glass flake lining at times. But from a longevity perspective, borosilicate turns out to be a better choice.
Hmm.
There are other materials available, but they are more cost prohibitive.
Right. And will you recommend FRP pipe inside in the flue for liquid collection? Do you have any reference for it?
We will be there are FRP is a good material for corrosion resistance, so we can definitely suggest that to be used. As far as references are concerned, I need to check a detailed engineering drawing for these particular items before I give you a clear answer.
Right. And sir, how has GE addressed the MOC issue, mock issue for chimney flue and ducting? What alternatives have been offered and accepted by customers?
So when we are executing in the current ongoing NTPC projects, we have fundamentally gone for borosilicate bricks, and because this is easier to execute at site and much easier to handle compared to other materials which are more expensive and also more difficult to execute, because if you have to do titanium welding at an elevation, it's a nightmare. It's something which we would not like to do because there are quality issues and complexity at site which is difficult to handle and execute.
And sir, in your slide number 8, what megawatt given quantum of work did you discuss?
I just talked about, I think I talked about 800, 2 into 660 megawatt.
Okay. Last question, sir. What is the shutdown time for connecting bypass for new FGD during implementation?
Again, it varies from project to project, and what are the how much, what is the ease or of accessibility of installation of equipment. It can vary depending on project to project. You might need multiple shutdowns. Typically, you might need shutdown to install the bypass dampers if you need to do, and then there are other shutdowns needed for hookup. It can vary from project to project, from 15 days to 30 days or 35 days, but this needs to be reviewed in detail.
And sir, do you have any reference of tiles lining inside the absorber?
Um, I need to check. I'm not sure about the answer. You're talking about acid resistant tiles.
Yes, yes,
If
I
you are,
guess,
then
yeah.
in one of the installations, it was done partially, which I am aware of, but not really a full installation with G as such.
I'll take one last question, sir. How can we optimize makeup water consumption in wet FGD?
Well,
Basically, how can we
and,
optimize water consumption?
the water consumption which is needed in a wet FGD is actually driven by the temperature of the flue gas. Depends on the amount of flue gas you need to cool down. That is something which will saturate the flue gases. So there had been strategies in the past that you use a GGH to bring down the overall water consumption in the absorber, but that really does not really turn out to be a cost economical option, because you might save some amount of water there, but you will end up spending a lot of extra power for the extra pressure drop. So on an overall perspective, you don't really save much. And as far as the water is concerned, you actually take out the water which is coming out from your cooling towers. A lot of it can be used in the wet FGD. So on an overall plant level, you may not really increase your water consumption in the wet FGD in a big way.
Okay, all right. On that note, we'll close the session. Thank you so much, Mr. Vajpeyi, for very patiently answering all the questions. And thank you for sponsoring the conference as well once again. So
Thank you.
it was
Thank you.
very insightful session, as you can make out from the questions also. And I would request you if you can type in your email ID here in the chat window, because a lot of participants are asking for it.
Okay.
Thank you so much, sir, for joining.
Okay.
Yes,
Thank you.
see you. Thank
Thank
you.
you very much. Bye.